good time of day. My name is Alexander Demirov, and my work is related to the development of hematite photanodes for photoelectrochemical production of hydrogen. And today I would like to say you about receiving two-layered particle size distributed films based on hematite hollow submicrospheres, its optical and photoelectrochemical properties. So firstly, I synthesized hollow submicrospheres, and the main feature of these particles is presence of pore inside the particles. And well known that the concentration of the vacancies near the pore is more than equilibrium. Also, we know that oxygen vacancies in hematite are donor dopters, and therefore the bottom of the conduction band near the interface wall pore is lower than at interface wall electrolyte. This structure provides a hydrocharge separation. So as you can see, the average particle size is equal 975 nanometers, and XRD analysis shown that these particles is hematite. So next step is receiving film. I received film based on synthesized powder by Dr. Blade method. I used mixture of aqueous solution of ferrum nitrate 3 and hollow submicron spheres. After glass, we used as substrate. The mixture was distributed over the substrate surface and annealed. The heat treatment mode is shown on the slide. Average film thickness is 2 micrometers, and also we can see two layers. First is nanoparticles, and second is submicrospheres. So XRD patterns for this film shown that the particles didn't change their phase composition, and additional peaks corresponds to tin oxide, which acts as conductive layer. Optical properties of the film measured using certified spectrophotometric measurement techniques on calibrated Carrier 5000 spectrophotometer. Based on spectral dependencies of transmission and reflection and film thickness, I calculated absorption coefficient, and as we can see, it have 4 absorption H, 3 corresponds DD transition, and 1 para-excitation process. Also, we can see that film have high absorption, high light absorption in visible wavelength range. So this slide shows the potential dynamic curve taken in the dark open circuit potential change under illumination and chromoamperimetric values at constant potentials taken under periodic illumination of the sample. As can be seen, the oxygen evolution reaction on set potential for this sample is about 0.9 volt, which is lower than similar photanodes based on hematite. When eliminated, the open circuit potential decreased by 238 microvolts, which indicates the photogeneration of charge carriers. It's interesting to change the current density during illumination at different potential. At potential of half volt, we can see classical behavior of photanodes. It's a spike in current density and then stable value about 5 microamperes. At the potential of 1 volt, we can see a typical photoelectrochemical behavior of the film. The current gradually increase according to one-phase exponential decay function. It's a red line. And this behavior may be due to the generation of holes with energy unsuitable for oxygen evolution reaction, but increasing concentration of these holes at electrolyte electrode interface led to formation of iron 4 ions, which can be increased kinetic of this reaction. The main conclusions on the work given on the slide. Thank you for your attention.